All right, chapter 7. Ooh, what happened there? Yeah, it's not too bad. Okay. Chapter 7, we're going to continue. It's all about integrals in here, okay? Or anti-differentiation is what they call it. But what is chapter 7's even name of it? Differential equations and mathematical modeling. We'll call it antiderivatives. Antiderivatives. Okay, so we're going to get through. This chapter is going to be 7.2 through 7.5, so we will skip 7.1. All right, so we're going to do 7.2a today and 7.2b tomorrow. So here we go. We're going to talk about two different things today. We're going to do the indefinite integral and U substitution. And U sub. All right. Indefinite integral and U substitution. What happened? Oh, he is good, yeah. Okay, now, you guys know how to find the definite integral. That's the integral from a to b, and we found that by doing antidifferentiation and doing all that stuff. Now, what we're going to do is the indefinite integral. Indefinite integral looks like this. It's the integral of f of x dx, and basically, it's not going to have an interval from a to b. Okay? It's just going to be for the entire function. We find its antiderivative. The only thing that you need to remember is, so your answer is going to be f of x, where capital F of x is the antiderivative. You have to remember plus c. Okay? It's very important because it's a family of functions having that. All right? So let's do an example. Here we go. Number 1.
Part A, or is it all?
Oh, this is part A. Part A is indefinite integrals. And then part B is U sub. Sorry, thank you. All right, so let's do one. Number 1. They're going to say to evaluate. You're not going to get like a number answer. You'll get a function answer. So we're going to evaluate the integral of x squared minus sine x dx. And there's an infinite amount of answers to this, and the way that we are able to do is we just write plus c on the end, because the c could be any constant, because what's the derivative of a constant? Is just 0. There you go. All right, so we're finding the antiderivative. So we're going to add 1 and then divide by 3. So we get x cubed over 3. Thanks. Megan. Okay. X cubed over 3, and then what's the antiderivative of negative sine x? Yeah, it's positive cosine x, and then don't forget, plus c. Okay, and that would be your answer. And if you want to check your answer, take the derivative of your answer. Whatever you get should equal whatever was in the integral. So the derivative of this is x squared.
Didn't we already do this?
Yes. That's why.
Is there a button on our calculator for this?
No, because it's not from a number. Yeah. Your calculator will do definite integrals, but it won't do indefinite integrals. Okay? All right, we did already do this, yes, and that's why I'm not really going to spend that much time on it. The book does give you a table of all of, like, a lot of them. So, like, it gives you these. See, like, the integral of cosine is sine. The integral of secant squared is tangent. So it gives you don't need to memorize all that, though. Just find the antiderivative. Okay, here we go, part B. Well, this is the main stuff. That's the stuff you've already done before, so I didn't want to spend too much time on it. All right, part B is called U substitution. U sub. Okay. So here we go. All right, so if you have the integral of f of x dx, okay? That's great. That's okay. It's wonderful. Also, if you have the integral of, Trevor, f of u du, that's okay too. Okay? But what's not okay is the integral of f of u dx. That's not okay. Okay? You have to have the same variables. So dx is the differential, f of x is the function, and they have to be the same. Okay? So that's going to be key to this u substitution. You have to have the same variable to integrate. So I'm going to show you how to do this. Integrate. So we're going to get some crazy integrals coming up. Not the easy ones that we've done all along, you know, but ones that ended up that were chain rule, that had chain rule in them, and then you have to figure it out, and they get a little complicated. But u substitution is a really good way to do these. Okay, so here we go, number 2. All right, we're going to evaluate this integral. It's the integral of sine x times e to the cosine x dx. All right, I'll let you write that down and catch up. See how complicated this looks? There's like 3 functions in here. We've got sine x, we've got e to the x, and we have cosine x. All right, so what they're going to do is they might tell you, a lot of times they will, or I'll tell you, to let u equal cosine x, because sometimes that's the hard part. You might let u equal sine x on accident, and then you can't do it and it doesn't work. I try not to make you guys do that. I mean, when you get to college, they might not tell you what u is. Okay, so here's what we're going to do. We're going to let u equal cosine x. So let's replace cosine x with u. So it's the integral of sine x e to the u dx. All right, and you think, oh, wow, you just made a mess of things, right? Because now I have x's and I have u's and I have all this stuff. Okay, so this is what we're going to do. We're going to go up here to where we let u equal cosine x, and we're going to find out what du is. Okay? So let's go ahead and we're going to take the derivative of u by doing du dx equals, so I take the derivative of u with respect to x on this side, so I get du dx equals a negative sine x, right? Yeah, derivative. Negative sine x. Okay? And so what I'm trying to do is this. So I have this equation with u in it, but I have dx and I need du. Okay, so I'm going to try to solve for dx in terms of du, so I have it there. So go over here and solve for dx. So you have du equals negative sine x dx, and then divide by negative sine x. So du over negative sine x equals dx. Okay, so now that brings me back over here where I'm going to replace dx now with this entire thing. I do, but oh, this is the magic. You ready for it? Can you see it? Does anyone see any algebraic foreshadowing? No? All right, here it comes. The integral of sine x, yes, e to the u times dx, and dx is du over negative sine x. And it's going to work out this way. It has to. That's the way they've planned it all to work out. And what I mean by it's going to work out is you're going to go ahead and get rid of your x's because something will reduce.
Will it be negative e?
Yeah. All right, so now we have the integral of negative e to the u du. Now, if you don't like that negative, guess what you can do with it? You can put it out front so it doesn't bother you. Okay, if you like it that way. All right, so now what I get is I have to find the antiderivative. What's the antiderivative of e to the u? E to the u. Don't forget the negative. So it's negative e to the u plus c. Okay, finally, the last thing that you want to do is you want to then go back and put your answer in terms of x. So what was u equal to way back when? Cosine x. So this is equal to negative e to the cosine x plus c. And if you were to take the derivative of that, you would get sine x e to the cosine x dx, because that's chain rule. Good, huh? It's a lot, though. Did you follow it okay?
Is the derivative of e, it's
Derivative of e to the x? Yeah, so if you have y equals e to the x, then y prime or dy dx is e to the x.
But if it was like 2x?
It's 2x, then it's chain rule. So if you have y equals e to the u, and use a function in terms of x, then you get y prime equals e to the u times u prime.
Okay, that's all.
Oh, okay, yeah, but this is the integral of just e to the u, so it's just e to the u. All right, number 2. I have like 4 more. Oh, you're right, number 3. Number 3, yeah. 3, 4, 5, 6. Yeah, and if you feel like you got them after that, that's okay. But they're different. Like that one had e's and signs in it. The next one doesn't. So here we go. It's the integral of x squared radical 5 plus 2x cubed dx. Okay? And they'll tell you what u is. U is usually like an inner function. Every now and then there's a weird one where it's not, but they'll tell you to let u equal 5 plus 2x cubed. Okay? And we're going to solve this. We're going to integrate this using u substitution. All right, so here we go. First of all, what I like to do is I like to just rewrite it. Okay? I have u equals this right here. So I'm going to rewrite this as the integral of x squared rad u dx. All right. Then I realize, okay, well, it's dx, and I need it to be du because I'm going to integrate in terms of u for u substitution. So then I'll go up to here, and I'll take the derivative. I'll find out what du is. Okay? So this would be du dx equals. So I'm taking the derivative of u with respect to x, so I take the derivative. Derivative of 5 is 0. Derivative of 2x cubed is 6x squared. Okay? Then solve for dx. That's what I'm trying to replace. So I'm going to multiply by dx on this side. So, yeah?
U doesn't equal square root of that, right?
So then, yeah, du equals 6x squared dx. And then divide by 6x squared. So du over 6x squared is equal to dx. All right, so we're going to take that entire thing here, which is dx, and we're going to plug it in. Yes, so things are going to reduce. That's what you want. If you don't have that, then something went wrong somewhere. All right, so we get the integral of x squared, square root of u, times du over 6x squared. Okay, let me show you how to clean this up really nicely. Well, first of all, the x squares are going to reduce from each other, and you end up with a constant. I always take those constants and move them out because they're constants, okay? I don't want them affecting what I'm doing. And so now all I have to integrate is the integral of the square root of u. Okay? All right, so this is 1/6, the integral of u to the 1/2 du, and this would be 1/6. So how do we find out what the antiderivative of u to the 1/2 is? Well, perfect, yep. You take the 1/2 and you add 1 to it, so 3/2. So this would be u to the 3/2. And then divide by 3/2 is the same thing as multiplying by 2/3. Okay? Are you okay with that? You don't want fractions over fractions. Anytime you have to divide by a fraction, just flip it and multiply it. All right, so we get, what is this? 1/9. U to the 3/2, what did I forget? Plus C. I'll tell you a secret, I always forget plus C. And then finally, last step, go back to what you had u equal to and substitute that back in. So we got to find out what u was. So we get 1/9, and u was 5 plus 2x cubed. And this is to the 3/2 plus c. Yep, that's your answer. Beautiful. Okay, so from here, this point right here, when we're finding the integral of it, you're finding the antiderivative. So the antiderivative of u to the 1/2 is to add 1, just like any, exponential, and then divide by that number. So it's u to the 3/2 divided by 3/2, which is gross, so we flip it, multiply it by 2/3. It's just like finding the antiderivative of x to the 4th. How would you find the antiderivative of that? You would add 1 and then divide by that number. It's going the opposite way. All right, ready for some more? Aren't these so fun?
Yeah.
I know, right?
That was very fun.
Good. Are you even paying attention? Number 4. Okay.
Whoa.
Would you like to try one? Are you ready? Yes. Yes, you are. This one's a pretty doable one, too. Okay? All right, here we go. X times the sine of 6x squared dx. What do you think u is going to equal here? Just take a guess, random guess.
6x squared.
Yes, it is. 6x squared. All right, you try this one, okay? You try it.
Many steps.
Okay. All right, so it's the integral of x sine u dx. So then a lot of people here will go du equals the derivative, which is 12x dx. Some people do it that way.
I just do du over 12x.
Oh, you just go straight to it?
I think I'm
So then du over 12x equals dx. And then we're going to take that and plug it in here. So you get the integral of x sine u times du over 12x. X's will be gone. And then I like to take that 1/12 out front. Sine u du. Oops. Yes. There we go. Sine u du. Oh, I don't know why I drew this. I did. That was dumb. Okay, so once you take the antiderivative, make sure, people, they forget to do that last step. You have to find the antiderivative sine of u, which is negative cosine. Negative cosine of u plus c. So putting everything together, I got negative 1/12 cosine of 6x plus c. Who got that?
6x squared.
Yes.
Now that I redid it, I made a mistake.
Squared. Me too.
I left it as 6x. I forgot to put the square.
Oh.
So I was like,
Right. Then the x's didn't reduce. Because
no, I didn't have it. I had it just as 6x. That's 6x.
the integral tells you to take the antiderivative.
What happens to that du?
Well, yeah, it's the integral and du. They have to be on both sides. All right, let's do, I've got 2 more. This one's a little tricky. Are you ready for it?
Of course.
Trevor, you need some harder ones. Here they come. All right, this one is tangent cubed x times secant squared x dx. We have to integrate that. All right, here this one's a little tricky because you can't tell what they want you to make it, but you're going to let u equal tangent x. It's kind of a little bit different. Let u equal the tangent of x. Okay, I'll walk through this with you. Yeah, all right, so it's the integral of u cubed secant squared x dx. And then up here, du dx equals, what's the derivative of tangent x? Secant squared x. Do you remember that one? Sort of. And then, yeah, you can just flip-flop those. So then we get the integral of u cubed secant squared x times du over secant squared x. That's awesome. You see what's going to happen there. I kind of skipped a step. I hope that didn't bother you. I multiplied dx over to this side, and then I solved for dx by dividing. So dx equals du over secant squared x. All right, so let's go ahead and reduce. Gone. And so we get the integral of u cubed du. All right, don't forget to actually find the integral of u cubed du, which is u to the 4th over 4 plus c. All right, finally, last step. Let's get rid of that u. Let's get rid of u. Tangent to the 4th x. Please don't write tan x to the 4th unless you put parentheses around tan x. But it's tangent to the 4th x over 4 plus c. And think about it. If we were to take the derivative of this, right? This would be the 4 would come down and reduce. This would be a minus 1, which would be 3. And then you have to do derivative of the inside of the function, which is tangent. So that's where you get the secant squared from. All right, one last one. Do you want one more?
No.
No? You're good?
Yeah.
Okay.
Is it different?
A little bit. It was just, they give you an integral with, bless you, dx over cosine squared of 2x. So what you should do is you should change that to the integral of secant squared 2x dx. You know, like, if you can make this better, simpler, then do that. Okay? All right, great job.